Hi, this is gonna be a short video and I'm just gonna get into it. It's about this string of comments, and this person, I think, he's trying his best, but he's not explaining anything in correct terms that John Gabriel is aware of, which is the core problem of this discussion that is way over his head. Luki Pool's head and John Gabriel's head, which, to be fair, he is technically correct that Archimedes actually did geometrically come to the specific answer, the geometric answer to the squaring the circle thing using the Archimedean spiral thing. And I'm not gonna explain all too much in here, but the point of this video is that that I didn't really explain things in terms of ratios over here, which I'm working on it, but this is how it would look like. So if the circumference to the diameter is the diameter to the perimeter, whereas the perimeter equals 4 times the square root of the diameter squared over 5, then pi to 4 times, well, this thing here again, equals 1. Since C and the P will be this is a reciprocal of this. However, this is in terms of the circle, but this is in terms of the square. And likewise for the square root version, this is how it will be denoted. And this is the reciprocal relation of the square root of the circle to the circle, and the perimeter of this circle to the square root perimeter of the square root circle, which is a reciprocal as again, but in another way. So this is to this and this is to this, but inverted order, so they're equal to 1, or 1 to 1 actually. But yeah, I'm not gonna get too much into nitpicking stuff, but this is how I would convey it. And there's lots of stuff that I've got into in previous videos, especially the ones that I've zoomed in this, but in essence, this diagram here really explains what I'm trying to explain as to why the measured values do not actually represent the hypothetical value of pi, since this value here can be interchangeable with, if you look up here, so this value equals to this, which is this one right here, in decimal form, in if and only if the measure is the value, which is not, but besides the point. And this equals to this, so this and this length here and this length here is equal if C equals this, but it's not equal to that. for the the false c as the false pi as inconstructible commensurate n equals n towards infinite-sided polygon perimeter, which is kind of ironic that the someone that really hates infinity uses an false approximation method using infinity when I don't even do that, which, yeah, kind of a disappointment in a sense that people like John Gabriel didn't quite understand what's going on. But anyways, this measure here is the 0.786 is this one here, which corresponds to this value here, pi over 4, but not the calculated mistaken approximation value that's represented over here. And the property that this has is that it's centered really, the perpendicular to the diameter. So this is the diameter, so this is the perpendicular. This is 1 and this is 1. However, if you do the same thing with this, you will not get the same center. It'll be off center, so that means the perpendicular to it is off centered. And why is it off centered? Is because the values used, presuming, so this value and this value, and this is like the midpoint between those two values on the line. So this is centered, but this is not. The circle here is off-centered. Even though it's centered in one axis, but it's not centered in the other axis. Oh wait, so this line is centered in this axis, but this line is not centered in this axis. So there's other stuff that I could get into, but I'm not gonna get into that, but rather get into this. This will be one example, and it'll look like this. If presuming I were to try to understand the square root of pi, I would use this. And this will be constant regardless of what the x would be, presuming it's a natural number of some sort, or any magnitude, which makes it a constant because it's not dependent on specific measured values, but rather scalable proportionality of a square that's reciprocal to the circumference, or the perimeter square that's reciprocal to the circumference of a circle that is derived from using the diameter of that circle. So this other d is not the diagonal of the circle, but rather its diameter, because everything is derived from using the diameter in this. And all you have to do is to divide the diameter, the square of the diameter actually, into phi. So the phi cut will be here. So it doesn't, you could do this with any circle, any diameter magnitude, it doesn't matter ultimately. And anyone could make a golden rectangle, and anyone who makes a golden rectangle can make this specific angle over here to then make a perpendicular from the diameter to this point using the golden rectangle. And I have an example somewhere else in my junk book, which is in progress and it needs a lot of work to be done. And so here I used the midpoint of the radius and dropped the circle or arc that's on this line, and extended this line, and use this point and this point to make a circle, a phi circle relative to the one circle. The phi 1 in this is in terms of the radius or the diameter, it doesn't matter. But in this context, it will be since I said phi circle, it's more of the diameter sense. And using that diameter with the perpendicular, not perpendicular, parallel line that's tangent to the circle, it could use this point to make a line over here, and that line will intersect the circle at a certain angle from the midpoint, and this angle would be used to then arrive to the perpendicular of this one from using this point. So you make this triangle here, the Kepler triangle that people like to cite, but so there's a Kepler triangle here, which then you could make the perpendicular based on this triangle from the from this diameter, which is not the same as the radius here, but anyways, the perpendicular is known through the perpendicular from the midpoint. So there's a use of the diagonal line, but the diagonal of the square line. And I'm just gonna go to this page. This is someone else's work. This person, Pai Umeni Uguisu. And this person has written lots of stuff throughout the years, and he has lots of examples as to why, like disproofs as to why the approximation is false. However, he hasn't conveyed it in terms of the ratio of the geometry used to arrive to the reciprocal of the circumference to its diameter. So in other words, I'm trying to say that this is the claim made here, and there's lots of disproofs, and based upon this being true And whether or not you agree with that or not, the point of my trying to say is that reciprocal is not truly pi in itself, but rather is the expression of that relation between pi and a square with the properties of pi. And that's all there is to it. I'm not denying pi as a constant. Okay, I'm just saying that there's a relationship of a specific geometry of a square that is derived from the diameter of a circle with any given magnitude. That's the point. It works on every single magnitude. It doesn't matter how big it is or how small it is. As long as it exists, it works. And whether you understand that or believe that or not, that's not my problem ultimately. So this what it would look like for the square root of pi. And if I just change this to square, it will look like this value. So it's really not just 4 divided by the square root of pi. It's more 5 square root 5. So it's more like 4x or d to the square root of 5, but more accurately in this manner that I have down here as the diameter squared divided by 5. But divide is more like not in terms of the measure, but more in terms of the geometry, the measured geometry of that relation from the square of the diameter, which then has been square rooted, and then since we're trying to arrive to the perimeter, we're multiplying that by 4, which is what this represents here. But for the square root of the circumference to its diameter, the reciprocal diameter to its squared perimeter will be this value here, this expression here to be more accurate, which can then be re-expressed in this way and then in this way. Okay, I don't know how much clearer I could make this, but I hope this helps my viewers and maybe some other people that I've mentioned, and I'll see you guys later. Oh, and do look into this guy's PDF. He really tries a lot, very hard to explain himself, but at the same time he doesn't explain how to make it scalable. He just explains, he just tries to explain things as everyone else does, but they all fall short because they don't explain it in terms of the arithmetic ratios or functions or whatever. So yeah, this means that the reciprocal perimeter or the square perimeter thing, this expression that I made here, this is my invention, so to speak, or my discovery. And whether any of you guys believe that or not, I don't care, but I'm the only one who has phrased it this way first that I know of. And if you know of anyone else that did, I've never seen it. No one has done it before me. However, what people had done before me was to arrive to this not this expression per se, but presuming the diameter equals to a specific measure of one to a specific perimeter of a square. That's not what I'm doing. And I've not only done that, I also arrived to the angles of not only the area square, but also the circumference square, or perimeter square of the circumference. And yeah, I guess that'll be enough. So just as an example, okay, I was just gonna show you this page. Presuming, okay, if this circle is a diameter 2, using this angle, you could come to know the side of the area square of this diameter 2 circle, or you could arrive to the perimeter square of the circle of the diameter 2 side, or you just multiply it by 2, by itself, to arrive to the area of that square. So there's an intricate relationship that the square has to the circle, and it's vice versa, and they're inseparable in a sense, in a specific geometry. And whether any one of you gets it or not, it's not my problem ultimately, but I do think that I have some problems in explaining these things. So this is yet another attempt to explain myself. And not all of this book is about math, and I'm more of a metaphysician rather than a mathematician. So please don't really critique myself. Not critique myself. I don't really try to get too hard on me for not having a degree in mathematics, which is useless anyways for me, because that's not really my expertise or anything that really that I'm interested in ultimately. So some of these are not really about that at all, but rather metaphysical relationships that has some things that are related to it that can be represented in certain geometric forms. But that's besides the point. I'd be rambling off. I guess that's enough for now. If you guys wanna complain about what I've done is wrong or whatever, well, you could do that under my video, or you could harass John Gabriel again, but I really prefer if you don't do that to him, because he has it rough and he has enough of our BS. And yeah, I've said enough. I'm not trying to call you out, okay? I think you're a good guy, but you really need to look into John Gabriel's book, articles, and his videos. He has made lots of videos, so
welcome.
You really should
Greeting.
You really should be careful critiquing him when you don't even really know what he's trying to say. So I'm not really defending you, but I kind of am to John Gabriel, in that John Gabriel's work doesn't really explain the things that I try to do, and I'm trying to bridge the gap between you guys. That's the point of trying to do. to meet you guys halfway. And if I don't do that for either of you, whatever, for one of you, that's better. Maybe. I don't know. I said enough. Goodbye.